Friends, in the last session, number 3, we have discussed about the production of phosphoric acid by sulfuric acid leaching process and hydrochloric acid leaching process. In sulfuric acid leaching process, we have seen the raw materials required, chemical reactions that are taking place there. We have seen the flow chart and we have discussed in detail about the production of phosphoric acid by sulfuric acid leaching process. We have seen the applications and the physical properties of phosphoric acid. In the second method is actually IMI process. Israel mining industries, they have developed that process. Here the phosphate rock is treated with or reacted with concentrated hydrochloric acid, and the hydrochloric acid is actually reacts with phosphate rock and forms phosphoric acid and calcium chloride. The calcium chloride is separated from phosphoric acid by extraction by using an organic alcohol like butanol or pentanol. And finally, the phosphoric acid is extracted from hydrochloric acid by water, and the dilute acid which is obtained in the mixer setter C is actually then fed to multiple effect evaporator, where phosphoric acid is taken out in the last effect evaporator as a bottom product, which is around 85% concentration. In today's the session is 4. Here we discuss about the production of phosphoric acid by electric furnace process. In the electric furnace process, the process is similar to up to the manufacture of or production of phosphorus from phosphate rock in the electric furnace, and this phosphate rock which undergoes decomposition and produces vapors of phosphorus. These phosphorus vapors are then actually converted into phosphorus pentoxide by oxidation with oxygen. So phosphorus pentoxide, the reactions involved are here phosphate rock plus silica as flux and carbon as reducing agent. It gives phosphorus, that is yellow phosphorus, and carbon monoxide and calcium silicate. This carbon monoxide can be separated, scrubbed, and can be used as a fuel because carbon monoxide is combustible. The phosphorus vapors produced are actually condensed to yellow phosphorus and it is stored under water, because if you take the yellow phosphorus out of water bath, it catches fire at room temperature. So this yellow phosphorus is then further oxidized in presence of oxygen to phosphorus pentoxide, and it produces carbon dioxide also. The phosphorus pentoxide thus formed is then absorbed in water, which gives phosphoric acid. These are the chemical reactions which takes place in this process. Then we see the flow diagram here. Here the process up to the production of phosphorus vapors is quite identical with the production of phosphoric acid by leaching process. And here the phosphorus vapors are produced and then burnt in ambient air in a combustion chamber. to produce phosphorus pentoxide. This phosphorus pentoxide is then absorbed in water, which gives crude phosphoric acid. The unabsorbed gases from the top of the absorber is sent to electrostatic precipitator to separate carbon monoxide from the entrained solids or the vapors of phosphorus pentoxide. Then the crude acid, phosphoric acid, is then sent to purification process wherein phosphoric acid is added to the treatment plant and sulfuric acid is added to that so that any calcium salts present in the phosphoric acid are actually converted into calcium sulfate, and hydrogen sulfide is bubbled to the phosphoric acid to remove the arsenic as arsenic sulfide, and powdered silica is actually added to the phosphoric acid for purification, that is to remove hydrogen sulfide which is formed because of the calcium sulfide which is present in the rock phosphate. This hydrogen sulfide is converted into silicon hydrogen sulfide with the powdered silica, and it is actually precipitated as sludge and it can be discarded. All the impurities such as calcium sulfate, arsenic sulfide, and hydrogen silicon fluoride, all these actually settle at the bottom of the purification unit and which can be discarded. The purified acid of concentration 85% is taken as a bottom product and it can be used in the. This is the process taking place, right? We'll see the process in detail here. The phosphate rock is ground mixed with a portion of coke requirement, then sintered and the noodles into noodles to obtain better electrical resistivity characteristic and to avoid entrainment of fines in released phosphorus vapors and carbon monoxide vapors. Screening is necessary to maintain the size control with the fines recycled to the sintering operation. Coke, grease, and sand are mixed in controlled quantities based on the phosphate rock analysis. The electric furnace is 250 to 300 volt AC three-phase design with power fed to one phase to carbon electrodes of 100 to 150 centimeter dia in the each phase. The feed charge is gradually dropped into the fused section of the furnace at 1400 to 1450 degrees centigrade, where the reduction of elemental phosphorus takes place. The furnace is kept under slight vacuum by fan in the downstream end of the plant so that the furnace gases move past to electrostatic precipitator to remove the dust and other foreign materials and then to a water cooled condenser. Liquid yellow phosphorus is collected under water for further processing. The phosphorus vapors oxidation is accomplished by an air combustion section downstream from the furnace exit. The phosphorus pentoxide thus formed is removed by spraying the hot gases with water. Some mist is formed which is then removed by a scrubbing section or system. The crude phosphoric acid of 85% concentrated is given sulfuric acid treatment to remove entrained calcium salt as calcium sulfate. A powder silica is added to remove hydrogen sulfide, and countercurrent scrubbing with hydrogen sulfide to remove arsenic as arsenic sulfide. The sludge is removed in a sand filter and acid can be sold as is or diluted to 50 or 75% grade. Next process is furnace process, that is oxidation and hydration of elemental phosphorus. This is actually used, I mean to say this process is used in remote areas. Remote area means remote area from the major phosphoric acid plants to produce phosphoric acid for small scale requirements. Here the elemental phosphorus is oxidized to phosphorus pentoxide and the phosphorus pentoxide is absorbed in water to phosphoric acid. This is the flow diagram. Here the phosphorus is from the electric furnace, that phosphorus vapors are actually sent to a combustion chamber where the phosphorus is converted into phosphorus pentoxide by ambient air. The phosphorus pentoxide thus formed is then scrubbed with water so that crude 85% concentrated phosphoric acid is formed. And the unabsorbed phosphorus pentoxide and carbon monoxide are actually sent to electrostatic precipitator or demister, where the mist, that is and mist and the phosphorus pentoxide is separated from carbon monoxide. The carbon monoxide can be collected, purified and used as a fuel because it is a combustible. The bottom product from demister is a solution of phosphorus pentoxide, that is dilute phosphoric acid. It is mixed with 85% concentrated phosphoric acid and sent to purification section or unit, where concentrated sulfuric acid is added to remove calcium salt as calcium sulfate. Powdered silica is added to remove hydrogen fluoride as silicon hydrogen fluoride, and hydrogen sulfide is bubbled at the bottom so that arsenic present in the acid stream is converted into arsenic sulfide. All these impurities, that is calcium sulfate, arsenic sulfide, silicon hydrogen fluoride, all these will settle as sludge at the bottom. The purified acid is taken out as a top product and it can be further utilized. This is the process. This method of production is used mainly to smaller customer requirement capacities remote from major phosphoric acid manufacturing facilities. Phosphorus is melted at 50 degrees centigrade and metered by water displacement to a steam jet ejector and atomized section of the combustion nozzle. Compressed air is injected around the steam atomized phosphorus droplets, and the exothermic reaction raises the gas temperature to around 2000 degrees Celsius. The entire chamber is about 1.2 meters in diameter and 3 meters long and is built with stainless steel with water cooled walls. Both vertical and horizontal units are used. The gaseous oxide, partially hydrated, are treated in same manner as described in the previous section of conversion of electric furnace gas to 85% concentrated phosphoric acid. I explained it before. The purification is still required to remove arsenic via hydrogen sulfide for making food grade acid derivatives. Thank you.